and welcome to Classroom Teaching. Students, in last video we have seen about uniform and non-uniform linear motion. Then we have seen the concept of acceleration, types of acceleration, that is positive, negative and zero acceleration. And in this video we are going to see distance time graph for uniform motion. First of all, let us see again what is uniform motion. Tell me, what is uniform motion? Uniform motion, it is nothing but if the object covers equal distance in equal interval of time, then it is said to be in uniform motion. So in this video we are going to draw the graph. So please stop this video, pause this video and get whatever we require. म्हणजेच काय, व्हिडिओ पॉज करायचा, जाऊन पटकन स्केल आणि पेन्सिल घेऊन यायची, त्यानंतर हा व्हिडिओ चालू करायचा, कारण तुम्हाला माझ्यासोबत ग्राफ ड्रॉ करायचा आहे. त्यासाठी ग्राफ पेपरची आवश्यकता नाहीये, बिकॉज द ग्राफ पेपर इज गिवन इन द नोटबुक, इन द बुक ऑलरेडी. टेक्स्ट बुक मध्ये ग्राफ पेपर दिलेला आहे, त्याच्यावरच आपल्याला ग्राफ ड्रॉ करायचा आहे. Okay, so let us start. Students, uniform motion means equal distance is covered in equal interval of time. So the table is given here, and in this table distance and time are given. So first of all, write down the scale. What is scale? On x-axis 1 centimeter is equal to 10 seconds. And on y-axis 1 centimeter is equal to 20 meters. Write down the scale first. Then draw the graph. Actually, you know how to draw the graph. Take the readings for 0, 0. That means at origin. The first reading is at origin. The second, for 10 seconds, 15 meter distance is covered. So take the reading of 15. If you are taking 20 here, then here at the middle 10 must be there. So between 10 and 20 in the center, definitely 15 is there. Or you can count it. 10 lines are present in between, and therefore each small line, it is of 2 meters. So take the readings in such a way and try to join all these readings which we are taken. So you can find it that it must be a straight line. That means all these points, they are on a line. That means they are linear. All the points are linear, and therefore this graph is nothing but a straight line. And what is the meaning of that straight line? Distance and time. That means time is directly proportional to distance. Proportionality is there. That means as the time changes, distance also changes, and they are proportional. That means equal distance is covered in equal interval of time. And that is nothing but uniform motion. So for uniform motion, the graph is a straight line graph. Then if we will see for non-uniform, motion, again the graph paper is there, readings are given there, and again the readings are between distance and time. So, but this time the motion is non-uniform. What is the meaning of non-uniform then? If the object covers unequal distance in equal interval of time. So for that, write down scale. On x-axis 1 centimeter is equal to how much we can take? 5 seconds. Only 35 seconds readings are given. So on x-axis it is written in this way. On x-axis 1 centimeter is equal to 5 seconds. On y-axis 1 centimeter is equal to, see the readings, maximum reading it is 58 meters. Count the lines which are present on y-axis and accordingly take the scale. So we will take 1 centimeter is equal to 10 meters. And then draw the graph. Write down in this way. So it is 10, 20, 30, 40, 50, 60. And on x-axis 5 seconds. So it is 5, 10, 15, 20, 25, 30, 35 as it is. And again draw the points. Take the points. What is the reading? 5. First reading is here in the origin. Okay. The second is 7. So count small lines. Each line it is of 1 meter. So you can easily take 7. You can count it. So take such readings and try to draw the graph. That means see whether all these points they are on a same line. That means whether it is a straight line graph or not. Tell me whether it is straight line graph? No. If you try to see, if you take a scale and try to see the points whether they are coming on a line, then definitely we can say these are not linear. That means the points they are not on a straight line. So it is not a straight line graph. And what is the meaning of this? The meaning of this is as the time changes, the distance also changes, but there is no uniformity. That means the object covers unequal distance in equal interval of time. So it may have any shape. So the graph, it is not a straight line graph, it has any shape. So it may be curved or it may have any shape. So this is nothing but the distance time graph for non-uniform motion. The next graph is given. It is velocity time graph for uniform velocity. Now we have to draw the graph between velocity and time. Velocity time graph for uniform velocity. Again, what is meant by uniform velocity? Uniform velocity means uniform motion. That means the velocity is not changing. Object is covering equal distance. And therefore the velocity is not changing. So the example is given, a train is running with the constant speed of 60 kilometers per hour. 60 kilometers per hour for 5 hours. 5 घंट्यासाठी ट्रेन 60 किलोमीटर पर आवर या स्पीड ने जाती है. The graph is given here. ग्राफ दिलेला आहे आपल्याला. काय? The readings on x-axis 1, 2, 3, 4, 5, 6, 7. That means we are taking hours. That means time. On x-axis we are taking time. 1 centimeter is equal to 1 hour. And on y-axis we are taking 1 centimeter is equal to 10 kilometers. So the readings are 10, 20, 30, 40, 50, 60, 70, 80. So these are in kilometers and these are in hours. Time. So draw the graph. The graph is given in the book. So train is traveling with a constant speed of 60 kilometers. So the readings are in this way for 5 hours. So the graph is in this way. It is a straight line graph. Here 60, first hour 60, second hour 60, third hour 60. So the velocity is given here kilometer per hour. So we are taking here velocity on y-axis and time on x-axis. Velocity, time graph. So the graph is a straight line graph. It is given in the book. You can easily see it. And try to count. Suppose we want to count the speed, the total distance covered between 2 to 4 hours by the train. How much distance can be traveled by the train between 2 to 4 hours? Suppose it is A, B, C and D. So within these 2 hours, how much distance can be covered? We can easily write down it. We know the formula for velocity. What is velocity or speed? Because it is linear motion, the train is going in the same direction. So velocity is equal to distance divided by time. So in this formula, what is distance? So calculate distance is equal to velocity into time. So what is the velocity of train? Train is moving with the constant velocity of 60 km per hour. So velocity is 60. And what is time? We are calculating the distance covered within 2 to 4 hours. That means 2 hours. So 2. So it is nothing but 120 kilometers. How much distance is traveled? 120 kilometers. पण हे कॅल्क्युलेट करण्यासाठी आपल्याला ग्राफची आवश्यकताच नाहीये. ग्राफची आवश्यकताच नाही. सो हाऊ कुड वी कॅल्क्युलेट इट? बाय युजिंग ग्राफ. ग्राफचा वापर करून हे कसं कॅल्क्युलेट करता येईल आपल्याला? Try to think what is the relation between this shaded area of this shaded portion and distance traveled. What is the relation between them? Calculate the area of this much shaded part. This is a rectangle. And we know the formula to calculate the area of rectangle. What is area of rectangle? So calculate ABCD, area of ABCD, area of rectangle ABCD. What is it? Length into breadth. So AD into DC. AD into DC. So put the values there. AD, it is nothing but on y-axis, AD it is nothing but 60. So it is 60 into DC. What is DC? DC it is nothing but 2 to 4. That means it is 2. 4 minus 2. So it is 2. So we get 120 kilometers here. From where we are taking kilometer, you can write here also. AD, it is in kilometer per hour. So it is 60 kilometer per hour into DC 2 hours. So these hours get cancelled, and therefore we get 60 into 2 is 120 kilometer. So area of this shaded portion, if we calculate, then it is nothing but same as the distance traveled by train within that much time period. 2 ते 4 असं आपल्याला 2 ते 6 काढायचं असेल तर काय करावं लागेल? हा एवढा शेडेड पोर्शन करावा लागेल, 60 into 4. So the area of this shaded or this rectangle shaded portion, it is nothing but the distance traveled by the train. So keep it in mind, because you require this knowledge in next article. Okay, so the next that we are going to see is the another graph that we are going to see now. It is also velocity time graph for uniform acceleration. Velocity time graph for uniform, instead of velocity, it is uniform acceleration. Uniform acceleration. Now the body is accelerated. See the previous example, the train is traveling with the constant speed of 60 degree. So whether it is accelerated, what is acceleration there? We know acceleration. Acceleration is equal to final velocity minus initial velocity divided by time. So in that case, train is traveling with 60 kilometers per hour constantly. So u and v both are same. So acceleration is 0 in that case. But now we are seeing the velocity time graph for uniform acceleration. Uniform acceleration means the body is accelerated, but the acceleration is uniform. That means the change in velocity is equal in equal interval of time. But definitely the velocity is changing. So draw the graph for that. We need not have to draw the graph. The graph is already given here in the textbook. See the graph here in this video. You can easily see the graph. The table is given. The time and velocity are given. The velocity is not constant. It is changing, but it is changing uniformly. That means the change in velocity is equal in equal interval of time. So the acceleration is uniform acceleration in that case. So the graph is given here, the scale and graph is given here. So we will try to draw the graph here. On x-axis it is 5, 10, 15, 20, 25, 30, 35, 40. That means time period is given, is taken on x-axis. On y-axis, all these are in seconds. So time on x-axis. Velocity is given on y-axis. And if we see the maximum velocity, it is nothing but 56 is given. So if we take, the scale is given here 8 meter per second. So on y-axis 1 centimeter is equal to 8 meter per second. On x-axis 1 centimeter is equal to 5 seconds. So write down the readings here: 8, 16, 24, 32, 40, 48 and 56. And as the change in velocity is also in the same way, if you can draw the graph, then the graph is like this. The readings are like this. because it is uniformly accelerated body, and therefore if we draw the graph, it is a straight line here. The graph is straight line passing through the origin. Now the question is asked, the velocity, the question is asked here. Let us see what is the question. From the figure, we can determine the distance covered by the car between 10 and 20th seconds, as we did it in the case same as in the previous example of train. 10 to 20 seconds. Now we are going to calculate the distance covered by this car between 10 to 20. So this is 10 to 20. So how much distance is covered between these two? We are going to calculate now. कसं कॅल्क्युलेट करणार? आपण रिलेशन मागच्या याच्यात बघितलं होतं, कशा पद्धतीने कॅल्क्युलेट करायचं ते आपल्याला माहिती आहे की इफ वी कॅल्क्युलेट द एरिया, आता हा एरिया असा झालाय शेडेड एरिया. इफ वी कॅल्क्युलेट द एरिया, then we can get, definitely we get the distance because the velocity time graph is there, same graph is there. The second point, the second option is calculate the average velocity. Take average velocity and average time. Okay, 0 to 32 आपल्याला वेलॉसिटी जी चेंज होतीये ती कुठून कुठपर्यंत होतीये आणि टाइम कुठून कुठपर्यंत घेतलाय आपण, हे जर आपण बघितलं, आपल्याला इथपर्यंत घ्यायचंय 10 सेकंड्स पर्यंत, 10 to 20. फक्त एवढ्याच शेडेड पोर्शनचा आपल्याला डिस्टन्स किती कव्हर झालं ते बघायचंय. सो 10 सेकंड्स, टेक द वेलॉसिटी 16 and for 20th second it is 32. If we take the average of these two, it is 24. Average 24. Average कसं कॅल्क्युलेट करतो आपण? 32 plus 16 divided by 2. So it is 24 meter per second. So the average velocity is 32 plus 16 by 2, it is 24 meter per second. And how much time is there? From 10 to 20. That means we are going to calculate the distance covered in these 10 seconds. So distance is equal to velocity into time. Velocity, it is nothing but average velocity we are taking because it is not a straight line graph. It is in this way. So average velocity is 24. So 24 into time is 10 seconds. So it is 240 meters. Distance is covered between these 10 seconds, 10 to 20. So we can calculate it for another example also. Suppose calculate the velocity or distance covered between 25 to 35. We can calculate. Take the average 25, so it is 40. 35, it is 56. So the average is 48. Okay, average velocity is 48 and time it is 10 seconds. So it is 480. So as the velocity is not constant, it is changing. Therefore, we can calculate the distance covered by using this formula easily. But as we see in the last graph, as in the case of example of train, we can calculate here also by using the area of this triangle plus area of this square. That means total area of this shaded part, it is always equal to the distance covered. And you can try it at home, because you well know that this area of the shaded portion, it must be equal to distance. Try to match it. हे करून पहा. हा शेडेड पोर्शनचा एरिया कसा कॅल्क्युलेट करणार? एरिया ऑफ धिस स्क्वेअर, ठीक आहे, लांबी गुणिले रुंदी, अँड एरिया ऑफ दिस ट्रायंगल. Add them. It must be 240. Okay, so we will stop here, and in next period, in next video, we will see about the equations of motion, and we prove these equations by using graphical method. So it is very important video. So okay, thank you very much.